Hello everyone and welcome to our research project presentation about assessment of thermal comfort parameters in the classroom blocks of the Faculty of Chemical Sciences at Balsai Campus, University of Cuenca. In this study, we investigate how students, teachers, and visitors experience different comfort factors like temperature, lighting, and air quality inside our campus buildings. And especially, we want to find out how we can improve it through smart and sustainable designs. To develop all this project, we built up on previous studies in a similar Andean and Ecuadorian context. Starting with a project close to home in Peru. This author analyzes the thermal comfort in a school in Cusco and proposes a bioclimatic improvement. In Ecuador, these two authors, Ledesma and Rivera, studied millennium schools in Quito and Babahoyo, highlighting the mismatch between important standards and local perception. And finally, for our last study, in a more close context, Astudillo addresses a school in Azores, evaluating real indoor conditions after modernization. All this study shows that the need for localized data-driven solution in education infrastructure. Next, we have our research objective and site. Our objective is to analyze the thermal comfort condition inside the classroom of the block of the Faculty of Chemical Sciences in our University of Cuenca, in order to identify architectural and environmental factors affecting comfort for the users. Using a mixed method approach, we combine technical measurements with the user's perception, integrating objective data and human experience.
To understand thermal comfort in the classroom block of the Faculty of Chemical Sciences, we will apply a mixed method approach. This will allow us to gather both objective data and user perceptions, providing a complete picture of how comfort is experienced in these academic spaces. For the quantitative part, we will install specialized instruments to measure environmental conditions such as air temperature, relative humidity, CO2 concentration, natural lighting, and air velocity in selected classrooms. Then, we will develop a virtual 3D model of the building using Design Builder, which will simulate the thermal and lighting performance of the classrooms. To ensure accuracy, we will integrate local weather data using MetaLARP, enabling simulations that reflect real weather conditions and parameters. Related to the qualitative methodology, we are going to make digital surveys using Kobo Toolbox to collect data on users' thermal sensations, their satisfaction with lighting, ventilation, and overall comfort inside the classrooms. The survey will be conducted with approximately 300 users, including students, teachers, and occasional visitors. Geolocation features will help us validate the exact areas referred to in each response. Finally, related to methodology, once we gather both the environmental and user data, we will process and analyze it using RStudio. That is how we will identify how well the building's design aligns with actual comfort needs. This comparison will also guide the proposal of passive strategies that will improve comfort based on both data and lived experience.
Based on the mixed methodology, we have planned 3 main activities. In the first one, the collection of information, plans, bibliography, climate data related to the classroom buildings of the Faculties of Chemical Sciences and Engineering at the Balsai campus. The second main activity is the processing of collected information. And the third main activity is the formulation of passive strategies for the thermal improvement of the classrooms. In total, we have 22 sub-activities for the developing of the project.
We begin with our project timeline structured across 18 months. In this Gantt chart, you can see 3 main stages. The initial phase from September 2025 to May 2026, dedicated to collecting architectural data, climate inputs, and preparing simulation models. The fieldwork phase, between April and August 2026, where we'll install environmental sensors, conduct measurements, and distribute perception surveys. The final phase, from July 2026 to March 2027, focus on processing data, modeling passive strategies, and publishing our results. This sequencing ensures overlap between field data and simulation, allowing early feedback to improve later stages.
Here we present our budget aligned with the timeline. You'll notice key peaks in expenditure during months 6 to 13, corresponding to equipment acquisition, field measurements, and software implementation. Budget allocations also include personnel, travel, and publication efforts, space to ensure resources are available when most critical. Our total project budget is $135,430, distributed as follows. Personnel accounts for over 50%, reflecting our focus on technical and academic rigor. Direct research inputs like Design Builder and Meteonorm support our quantitative analysis. Fieldwork costs, including travel and subsistence, enable consistent in-situ measurement. Finally, dissemination and indirect costs support reporting and institutional alignment. Funding is secured through institutional support and university research programs. This research, titled Assessment of Thermal Comfort Parameters in Classroom Blocks of the Faculty of Chemical Sciences at Balsai Campus, seeks to analyze how architecture and environmental influence indoor comfort. The state-of-the-art reveals a regional challenge. Schools and universities often adopt standardized designs without adapting to local climates. Studies in Peru, Quito, Babahoyo, and Sogues all point to this gap and the need to combine technical measurement with user perception. Our mixed methodology integrates simulation-based modeling with in-situ environmental measurements and user surveys using Design Builder and Meteonorm. We simulate lighting, temperature, and airflow in classroom blocks. In parallel, we use Kobo Toolbox to collect perception data from over 300 users, including students, teachers, and staff. By comparing measured and perceived comfort, we aim to formulate passive design strategies to improve classroom conditions, all based on empirical data, user needs, and feasible interventions. Thank you.